Let me start by saying that this graph looks so weird because we are getting photoelectrons being emitted from both plates E and F. Usually we shine light on only one of the plates, but in this question, we are shining light on both the plates. And we are getting photoelectrons from both of them, and that's why this graph looks so weird. This graph here actually looks very normal. The reason is because even though we are shining light on both the plates, only one of them is emitting photoelectrons. The other one is not. So let's first try to identify which one is showing photoelectric effect and which one is not. Let's look at this graph here. The axis here says that on this side of the graph, we are making plate E positive. Making plate E positive is trying to attract the photoelectrons being emitted by plate F. So in fact, what we are seeing here is the saturation current for plate F. On this side, we must be making plate F positive, right? If on this side we are making plate E positive, this side must be making plate F positive. By making plate F positive, we are trying to attract whatever photoelectrons that's being emitted by plate E. So this part of the graph should correspond to photoelectric effect of plate E. But is there any current? No, right? That means plate E is not emitting any photoelectrons. So for the same wavelength of light, we get photoelectric effects from F, but not E. That tells us that it's harder to knock electrons out of plate E. That means the work function of plate E must be higher than the work function of plate F. Okay? Let's come back to this graph. So on this side, making plate E positive is trying to collect the photoelectrons of plate F. So this is the saturation current of plate F. Whereas on this side, we are making plate F positive. So we are trying to collect photoelectrons from plate E. So this is actually the saturation current of plate E. So now, realize one thing. When we were using lights with wavelength lambda 1, we could only get photoelectric effect from plate F. But when we change the wavelength to lambda 2, we can knock out photoelectrons from both plate F and plate E. What does that tell you about the photons being used now? The photons being used now must pack more energy, right? So higher energy must mean a shorter wavelength. That means lambda 2 must be a shorter wavelength than lambda 1. Okay, I hope I've made everything clear. That's all. Ta-ta.